Hello everyone, welcome to Maans Chandigarh IS Academy. As we have started with our science and technology classes for the examination, and I have been covering topics from space, science and technology. So we'll continue with our discussion here, and you all know that question will be dynamic in nature, that will be connected with current aspect. So we have already covered about launch vehicle technology. That part we have already covered in the previous session there. Now what I am coming here, we will be discussing about important ISRO missions, that is space missions here. So you can get questions on important space missions of ISRO. So here, whatever the past missions, particularly the important one, you could get a question there. So what we are going to cover in this session is that first we will study about lunar mission. Very, very important for the examination. So here we will see about Chandrayaan missions. And you all know that India has created achievement by landing on the south pole of moon, that is a Chandrayaan 3 missions. So we will see in today's session and what is our plan for our future, Chandrayaan 4. Now another very important achievement of our space program, that is an interplanetary mission, and in that context what becomes very, very important, that is a red planet Mars mission. So we're discussing about Mangalyaan mission, but now ISRO is planning for Shukrayaan, that is a study of Venus, the twin planet. So that is one. Then about mission to study sun, you all know Aditya L1 mission. Another very important astronomical mission, you can say. At the same time, India has already launched way back in 2015 AstroSat, and the last year India launched a very important satellite called XPOSat, X-ray polarimeter satellite. So we'll see the solar mission. So in this context becomes very important, Aditya L1 mission, Lagrange point 1, that mission there. So let us go through this topic one by one and cover the different important dimensions in terms of mains exam and the answer writing part of it. So we'll be now first discuss about lunar mission. So what type of question you can get? You can get direct question. Okay, what is the relevance of Chandrayaan 3 mission for India? Suppose you get a question, what is the relevance of Chandrayaan 3 mission for India? Discuss important highlights of Chandrayaan 3 mission. Right, direct question can be asked where 200 words you have to write answer, right? Or it can be connected with future program, Chandrayaan 4 mission. So let us look into that. So lunar mission, Chandrayaan mission. So when you are writing the answer, right, you have to bring all important facts and dimensions. So when you say Chandrayaan missions of ISRO, so we can understand in this 4 aspects, past and future, right? So now let's look at here, first mission here. See, when your answer, you have to always give some kind of a background understanding. Chandrayaan 1. So what is the first thing here? This was planned in 2008. So October 2008 it was launched. So here it was launched in 2008 by, now you will be able to understand because we have already covered what is PSLV, what is GSLV. So by PSLV, Polar Satellite Launch Vehicle C11, that was a C11. It was the first extra large XL version of PSLV. That was used in the mission. Polar Satellite Launch Vehicle, a very reliable space vehicle for India, that was used for Chandrayaan 1 mission. Now Chandrayaan 1 mission, in the Although October, November, that time we have launched, but it reached to the lunar orbit, Moon's orbit, 100 kilometers above the surface of the Moon. So here it was an orbiter mission. Orbiter mission, where we placed Chandrayaan-1 orbiter into 100-kilometer orbit on the Moon. So orbiter mission, where Chandrayaan spacecraft with all important payload instruments, right, was inserted into 100-kilometer orbit around Earth's moon. Right? Now it carried 11 instruments, not only India, even Luxembourg, USA, right? 11 instruments were there to study different aspects of the moon. So here, even NASA participated in this mission there. 11 instruments. As payload. Now, although the mission has to be ended earlier, that means the mission didn't last for the designated time span. There was some problem with respect to thermal system of the spacecraft of Chandrayaan-1. So we have to end the mission earlier. But there have been certain achievements of Chandrayaan-1 orbiter. This orbiter, which went around the moon, on the top of the orbiter, there was like a hat-like instrument called MIP, Moon Impact Probe. That was dropped. Into the on the moon. So as it passed this MIP to the atmosphere of the moon, it was able to detect loss of water from the surface of the moon. That is one of the very big achievement of Chandrayaan-1 mission. So here, if you look at here, achievement of this mission, so what we can say here is that detection of the loss of water from moon surface. That was caught by the instrument called MIP, Moon Impact Probe. Right? It also did the mapping of the surface of the moon, study about the atmosphere of the moon. So 11 instrument was very important, were very important to get all the data about the moon. So this is one of the first beginning what we had. Now we planned for Chandrayaan-2 in the year 2018. But it got delayed for 1 year. So Chandrayaan-2 mission. Now if you compare with Chandrayaan-1, the first thing is that it was launched in 2019. Why it got delayed? The reason is that it was not only orbiter mission, but also lander mission. Vikram lander carrying the Pragyan rover. So the entire technology to be developed, its spacecraft, its module, its instrument, right, required a lot of carefully designing, development. And initially we were collaborating with Russia. But whatever the reason, Russia partnership didn't work. So ISRO decided to go alone to develop indigenous technology for landing. So it got delayed for 1 year, 2019, by not using a PSLV because it was heavier. PSLV can go up to 1340 kilogram payload capacity. We have discussed in the previous class. Here we went for GSLV by GSLV Mark 1, that is called MK1, MK2, MK3. So we went for GSLV Mark 3. Which one we have used? GSLV MK3, the heaviest rocket of India, and this is called M1, Moon 1, right? M1, Moon 1, right? Now, what was the second thing, very important thing? 2 modules. It carried 2 modules. First one, orbiter module, which is still right now working. And second, lander, to land lander module, that is called Vikram, named after founding father of India's space program, Dr. Vikram Sarabhai. Vikram lander with a rover, 6-wheel rover, to move on the surface of the moon, that is a Pragyan rover. So rover Pragyan was inside the Vikram lander. So these 3 modules. Now we were able to reach the moon, still lander with the instrument there working, but we failed in the landing, right? So failure in soft landing. Soft landing on the south pole of the moon. The target site for landing was southern pole of the moon, what we call dark side of the moon, right? South pole of the moon. Now question is, why southern pole of the moon, south pole of the moon? The reason being that crater, there the crater may harbor water, ice-like water, because sunlight is less, and there might be a discovery of water. But unfortunately, we failed there. We were not able to control the speed of the spacecraft, that lander, Vikram lander, and then last moment it just crashed on the surface of the moon. Now this site where our Vikram lander with Pragyan rover crash landed, that site has been named as a Tiranga. That site has been given by the government now. So now our next mission was planned for soft landing properly on the moon. Chandrayaan 3 mission. Now Chandrayaan 3 mission, this was launched in 2023. Although we were planning for the next year after 2019, but why it got delayed? Because of Corona call, you know that, COVID-19, right? That started from 2020-21. So many of the missions were postponed. So launched in 2023. Again, GSLV MK3 Mark 3, M3 mission, right? But here again 2 modules. Again, it had 2 modules. But here the orbiter, the role of the orbiter was to assist, help, propel in a proper landing of the Vikram lander with the Pragyan rover, right? So the main purpose here was not to orbit with the instruments and then take all the observation. Already the Chandrayaan 2 orbiter with the instrument is already working right now. So here the first one was orbiter propulsion. Which can help in a proper landing, soft landing on the moon. And second was, you know that, lander Vikram with Pragyan rover. And we were successful in soft landing on the moon, dark side of the moon, south pole of the moon. And you know that this site, when we landed at 23rd August 2023, a landmark year, 23rd August 2023. That time Russia was also trying to land, but Russia failed. So India was successful in soft landing to the south pole of the moon. Right, we are the first nation to reach there, soft landing there, and that site has been named as Shiva Shakti. Failure land site was named Tiranga. Another very important thing is that this mission, 23rd August 2023, has been declared as National Space Day of India. Last year, 2024, we observed first time National Space Day. This year again, we observed Space Day. Lot of activities, public awareness, lot of areas of interest of science and technology, right? Programs have been carried out in the country. The successful landing on the South Pole, Shiva Shakti, South Pole of the moon, and Pragyan rover had an instrument which came out there and did sample analysis, rock analysis, temperature of the soil of that area. Around 500 meters around that, Vikram lander can move around. So we got a lot of data there. But again, we are now planning for future Chandrayaan 4. That is on the card. Fourth mission, lunar mission of India. Now, this is planned again here. Planned for 2026. Again, by using a GSLV. Now, what is the main aspect of this mission? We will not only have soft landing on the moon's dark side or south pole, but we will also collect the sample, lunar sample, and then we return to back to the earth. So here, what is very, very important is that mission profile. So we will have a soft landing, same as Chandrayaan 3, on the moon surface, and collect lunar sample. And return back to Earth. This is going to be another challenging mission for India. Return back to the Earth. That is going to be planned for Chandrayaan 4 mission there. So I am giving you now a part of understanding for your answer writing part of it, right? Now let's look at the interplanetary mission there. So already we have accomplished one, and then now we are planning for the next, and then follow on mission for Mangalyaan. So if you look at here, so Mars orbiter mission, MOM. What do you call Mangalyaan? Earth and the Mars, right? Now here, when you look at here, the Mangalyaan mission. So what is the first thing here? It is the first interplanetary Earth and the Mars red planet mission of India, of ISRO. India becomes the first country in the world to have successfully orbited the moon, even the Mars, orbited the Mars, even NASA failed in the first attempt. Russia tried, failed, China tried, failed, European space tried, space agency tried, failed. India is the first country, and very economical mission. You know that you have seen the movie Mission Mangal. Akshay Kumar, Vidya Balan, that movie has showcased that, and the women scientists of ISRO, their contribution comes there. So India is the first country in the world to orbit Mars planet in the very first attempt. So when you write answer, you have to write this point there. Others failed in first attempt. Right? Now China has reached there. China has also reached the Mars. And China not only now reached the Mars but also landed on the Mars. But when we did this Mangalyaan mission, China has not reached. And that time we were the fourth country in the world. But now, presently, if you look at, since China has reached there, so we become the fifth country in the world to be orbiting the Mars. So here, first attempt there. Now, Mangalyaan mission here, that was launched in 2013 by PSLV. We used PSLV C-25. It was the Silver Jubilee of PSLV. They launched in 2013 by PSLV and reached Mars in 2014. It almost took 9 months journey. Just like a mother gives birth to a child. That's why the name is MOM, Mars Orbiter Mission, to reach the Mars. 24th September 2014 is another landmark year in the history of space program of India, where India's Mangalyaan reached the Mars orbit. So that's what 2014 becomes very, very important. Now, it carried 5 instruments. It carried 5 instruments as payload. It carried 5 instruments as a payload, right? So here, as payload, to study a different aspect of Mars. So to study exoatmosphere, outer atmosphere of Mars, right? Then surface, then minerals, then again detect methane, because presence of methane gas can indicate the presence of life in the Mars. How it can be indicate? Because maybe some kind of microorganisms, anaerobic conditions may release methane gas. So detection of methane gas, then detection of water. Is there water presence? Present detection of water in the Mars, because then it will become in future habitable there, right? So Mangalyaan mission, after completing 10 years of service, we have now decided to retire Mangalyaan 1. Now ISRO is planning for Mangalyaan 2, the next orbiter mission. That's what we are planning here. At the same time, we are also looking for landing on Mars, right? Landing on the Mars planet there. Now, second, what comes here? Venus orbiter mission. What we have given the name Shukrayaan. Shukra is the word for, Hindi word for planet Venus. Shukrayaan there. There another mission we are looking for. Now Shukrayaan here, this will be second interplanetary mission of ISRO. Right? Of ISRO after Mars planet. And you know that here will be a study of planet Venus, which is also called evening star. morning and evening star. It looks into, and it is a twin planet, almost the same type of density, mass, size of Earth. And it has a very bright, looks bright in the evening, in the sky, just looks like a star because it reflects the sunlight. Its atmosphere is full of carbon dioxide gas. And you know that carbon dioxide gas is a greenhouse gas, right? So it's very, very hot planet there. So evening star, that what is called twin planet of Earth. Very less study has been done with the Venus. So that is going to be a very landmark study here. Going to the Venus, and it will be a orbiter mission, again, orbiter mission. And we are planning for 2026-27 time frame there. With the instruments and every for will be there. That what we are looking for, Shukrayaan mission. So we'll study about the planet's atmosphere, then also gaseous composition. As I said, carbon dioxide gas is more abundant in Venus atmosphere. We'll have those instruments which will penetrate and see the surface features and temperature and other, all those studies will be there. And also try to investigate that is that, as saying twin planet, the mass density, everything of the Venus compared to Earth, and at the same time during the origin of solar system, how these two planets got formed, Venus and the Earth. So that will be again a very interesting aspect from the space mission program. Now we'll come to study of Sun, Aditya L1 mission. Let's go to the Aditya L1 mission. Solar mission. Very important for the exam. You could get question in the examination. Aditya L1 mission. The name is also very much, word which connect with the sun, Aditya. So what is the first thing here? India's first spacecraft. Right, to be placed in a halo orbit. What is something called halo? Halo orbit around Lagrange point 1. I'll explain what is Lagrange point and halo orbit. L1 at a distance of 1.5 million kilometers or 15 lakh kilometers from Earth. $1.5 million kilometers or 50 lakh kilometers away from the Earth. Now let's understand here. Two key terms, halo, Lagrange point. Halo orbit is a three-dimensional orbit. It's a 3D orbit which is there around Lagrange point. Now the question, what is Lagrange point? Lagrangian points, this concept given by Joseph Louis Lagrange. He said that in the outer space, when you have two heavenly bodies, let's say Earth and the Moon, or Sun and the Earth, any two celestial bodies, heavenly bodies. So what is the theory says? There are 5 Lagrange points around these two heavenly bodies, whichever you take, Sun, Earth, Moon, you take any two bodies. 5 Lagrange points are there. Out of the 3 points, L1, L2, L3, they are on the straight line, joining the two heavenly bodies. And L4 is ahead, L5 is behind. So these 5 points are such points where gravitational attraction of both the heavenly bodies balance centrifugal force. of both the bodies. Outward force, centrifugal force of both the bodies are balanced with the gravitational pull, attraction of the two bodies on those 5 Lagrange points. So if you take Sun and the Earth, if you look at the Sun and the Earth system, Sun and the Earth system. So what the concept says here, that Sun and the Earth system, it says that L1 point will be between Sun and the Earth and L2 will be behind the Earth. Equal distance. Will be equal distance here, right? Will be equal distance here. This is the Earth, right? Now, if we join a straight line, right? So L1 is here. And same distance L2 will be here. Lagrange point 2. 1.5 million kilometer here, 1.5 million kilometer at the back side. L3 will be back of the Sun here. Whereas the L4 ahead and behind. That means as Earth revolve around the Sun, as the Earth revolve around the Sun, right? As Earth revolve around the Sun, so these points move in the space. So when you look at L4 points and L5 points, it basically make a 60-degree angle with Earth and the Sun, like equilateral triangle. Whereas L1, L2, L3 are all in the straight line. They are in the straight line there, right? So if you look at here, it makes 60-degree angles here. So L1, L2 and L3 points, they are on the straight line joining Earth and the Sun, right? And L4 and L5, right? They are ahead and behind Earth and form equilateral triangle, that is 60-degree angle with Sun and 60-degree angle with Earth. With Sun and the Earth. And when you look at L1 equal to L2 equal to 1.5 million kilometers, or 15 lakh kilometers. Now what is halo orbit? When you say halo orbit, so halo orbit is a point around this Lagrange point. So it is not on the point kept spacecraft, it is around that point it moves. And what is the balancing force here? The gravitational pull of Sun and the Earth, that balance with the centrifugal force, outward force generated by Earth and the Sun. So it is a kind of equilibrium here. It's a kind of a equilibrium. So here Aditya spacecraft is here. This is Aditya, which I am drawing in the pink color. So it is moving in this halo orbit. Aditya is moving in this particular halo orbit. This is called halo orbit or three-dimensional orbit. And this is the Aditya spacecraft. Now, why we kept here? The reason being that it's direct line of sight with sun. It's directly observing the sun, right? L2 will be behind the earth. So, observation sun will not be possible. And L3 will be very, very far away. Whereas L4 and L5, problem is that not only distance from the earth, but also there are some kind of natural bodies like meteorite or some kind of asteroids here, which may hamper the observation. So the best point is the L1 between sun and the earth. Now, what is another thing here? That if you look at moon is 3,84,000 kilometers away from the earth. Earth's moon is 3,84,000 kilometers away from the earth. Average I am giving the distance. And L1, Lagrange point 1, is around 15 lakh kilometers. So that means L1 point is even much far away from the moon. So what is that advantage? The advantage is that there will be no effect of eclipse, what is called occultation. Moon is here, 3,84,000 kilometers. Earth is 15 lakh kilometers. So there will be no impact of any shadow of the eclipse on the Aditya spacecraft. So there is no impact of eclipse, right? Now what is very, very important, which I would like to add here, that what we are trying to study about the sun, right? We are the, ISRO is the third agency. ISRO is the third agency in the world. Is the third space agency of the world to use L1 point. Other two are, one there, NASA, American Space Agency NASA, and ESA, European Space Agency, Europe. Already on L1 point, there is a mission to study sun, what is called SOHO mission, which stands for Solar Heliospheric Observatory. Solar Heliospheric Observatory, SOHO, right, is a ongoing solar mission of NASA and ESA. In another halo orbit. Halo orbit is what? Is a three-dimensional orbit. But the point is same, L1 point. Another halo orbit around L1 point. One halo orbit, 3D orbit, India is using. That is a Aditya mission, Aditya spacecraft. Second is used by SOHO, right? Now, what is the third thing here? Aditya L1, right, was launched by PSLV, not GSL, Polar Satellite Launch Vehicle. Already last year it is there, so we have launched there, right? So we have already launched, and this could be a question in the exam. You can get mains question here, right? 2024, it is there. So PSLV carrying 7 instruments as payload. As a payload to study what are the objectives here that I would like to add here, because when it comes to the question, then you have to write about those objectives there. To study following things here. First, temperature difference between the outermost corona, you know, the outermost part of Earth, right? But if you compare the outermost atmospheric part of the sun, so sun's outermost atmosphere has very, very high temperature, millions of degrees centigrade. So between the outermost corona, what is called here coronosphere, corona, that goes lakhs of degrees centigrade, and the inner side, that is a photosphere, which has a temperature of 6000 Kelvin. What is here? The outermost part of sun is very, very hot. Temperature reaches millions of degrees centigrade Celsius. Whereas inner part, what is called photodisk, photosphere, that has temperature of 6000 degree Kelvin. Anomaly, temperature anomaly. So this is the mystery of the sun that we are trying to investigate. Second, here study, sunspots, which are dark spots in the corona of the sun, but it's because of high magnetic, activity, magnetic flux, right? And the sun is made of plasma, ionized gas, hydrogen and helium gases are present, and they're ionized because of high temperature. So the particles which moves, that create that flux. So photo sunspot, which has a lower temperature, they're present on the corona, high magnetic activities. So sunspots of the corona, and one very important event which happens in a cycle of 11 to 12 years, solar cycle, right? That is called coronal mass ejection. What is something called? And coronal mass ejection. CME. So this corona emit powerful waves, This is also called as a solar flares, solar storms, solar flares, which come out of the corona of the sun. Massive, very high energy, very high speed, velocity, powerful waves and particles from the outer corona. It comes out. And sunspot, that activity that can be reason of that. So solar wind, solar storm, that is studied there. So if I draw a diagram here, so sun, this flares, this come from corona. What you say, solar flares, or we say coronal mass ejection. It ejects from the outermost part of the sun, and it reaches to the earth. This comes to the earth, right? And it affects the atmosphere, aurora borealis, lighting in the sky. Even it affects our ionosphere. It also can dislodge or create problem for our communication satellites, our GPS satellites, navigation satellites in the outer space when this powerful wind or flare reaches there. It can affect the magnetic field, magnetosphere of the earth, that could be affected there. So that's what it becomes very, very important, crucial, that this type of event need to be predicted in advance. Otherwise, there are damage caused to the satellite and the system and can have negative impact. So our Aditya is able to predict, will be able to predict such kind of solar storm. Such kind of solar storms will be able to predict. When this wave, so it has a direct impact on the solar system. It has a direct impact on the solar system. Right? Yes, the climate change, or you can say that simply even the space weather can be affected because of this solar wind, solar flares. Right? So we have a lot of satellites. If you look at here, we have so many type of satellites, communication satellites, navigation satellites are there. Even power grid failure could be there. So if you look at this CME impact, solar flares, so first thing is that satellite system, whether you take communication satellite system, GPS satellite systems are affected. Again, terrestrial communication, ionosphere get affected. Even sometimes radio waves, microwaves, they all come from the ionosphere. They're lighting in the sky, auroras, borealis in northern light, Australia southern light. Particularly the northern light get affected more. Australia is affected. You have a lighting in the sky. Even power grid, Iceland, Greenland, Canada affected. Airlines, aeroplanes which are flying in the sky, if this is the wind coming, get affected. Astronauts who live in the International Space Station. Where is the space station? Low Earth orbit. International Space Station. If they get impacted by the solar wind, the health impact. right? That could be the part. Magnetic field of the earth can get affected. So when Aditya will be able to give us the warning, early warning, because of continuously getting the data from there, coronal mass ejection, that can give us warning there, right? There's a third thing. So here, what is third thing here? Third thing is that impact. To study what? Impacts of coronal mass ejection, that is a solar wind, solar flare on space weather. And the fourth thing is that study of magnetosphere of the sun, the magnetic flux which happens on the sun, that will also be affected. And you know that this could be a part of question asked in the exam there, right? All those negative impact which happens there. So that's what it becomes very, very important that you should know this objective for what this Aditya mission is working there, right? So when you are writing there, if you remember the facts and the objectives of the mission, you will get marks. There can be single question on Aditya mission where you have to write in 200 words. So I have covered lunar mission, I have discussed Mangalyaan, Shukrayaan and Aditya mission. So we will carry on our discussion in our next session there. For any kind of doubt, any kind of thing which you find it, you can always get back to Maans Chandigarh IAS Academy. I will always be very happy to resolve your doubts. Our team will be always there to help you there. So I'll see you soon in my next session there. Till then, take care, be happy, prepare for the exam. Thank you.